Hey, so this is Mrs. Hickman. This is going to be my second part to talking about limits. So let's go ahead and get started, okay? Okay, so first thing we're going to do, sometimes you can't just plug in an area by substitution. You're going to have to graph it, okay? So, for example, if we were to put in 2 here, we would get 0 in the denominator, okay? That can happen, so let's go and look at this graphically. So I'm going to go to, set my window to zoom 6. Okay. Cool neat fact about here, if you don't know already, to make a fraction in a calculator, it's just alpha y equals, and you get your numerator of denominator right there. So that's going to be x plus 1 over x squared minus 4. So let's see where it's going to be as it approaches 2. Now, if you could already tell, it's going to be a vertical asymptote at 2, okay? Because anytime you have just the regular algebraic expression in the denominator, it's going to be a vertical asymptote, okay? So let's look here. So the limit as x approaches 2. Okay, so 2 is around there. So let's click closer. You could also use a table. I just like you looking at the graph, okay? So we're at x equals 0. Let me get closer in. So we're at x equals 0, and then I'm going to use my key buttons right here to move where I'm going to go. Okay, so let's see where it's going. Let's go to x equals 2 from the left. So the limit as x approaches 2 from the left. Let's see. Okay, so we're getting closer to 2. And it looks like it's pointing, whoops, it's pointing downward. Now remember, we are looking for a y value. So the y value where it's going is going to be negative infinity. Okay, so it keeps going and going and going until it approaches 2 to around negative infinity, whatever that number is, okay? So we could say that the limit as x approaches 2 from the left of f of x is negative infinity. Let's go on the right, okay? Let's go over here, okay? So now we're going to approach 2 from the right. So we're going, okay? So again, we're going up. So remember, you're looking for a y value. So up in y is positive infinity, okay? So my limit as x approaches 2 from the right of f of x is positive infinity. So if you can remember from the other video, are these limits going to exist? No. They would only exist if this and this were the same, and they're not. So this limit does not exist. So D and E does not exist. Okay? So this one, you're like, okay, it's the same problem. If I put in 0 here, yes, sine of 0 is going to be 0, and of course that's going to be 0. Okay, but algebraically speaking, it's kind of cool because all you have to do is just ignore the fact that there's a sign there and just cross off those x's, and your limit is going to be 2. So let me show you how that's going to happen. So y equals sine of 2x over x. Okay, so we're looking as x approaching 0. What y value does it get? It gets 2. Okay, so here's 0. So trace, you're going to put a 0. You're going to get an undefined number, but let's look from the left. It is undefined because 0 can't be in the denominator. But the best thing again about limits is they count undefined values. Okay, so let's approach 0 from the left. So let's get closer and closer. Looking at your y value right here, that's where your answer is going to be. So negative. Okay, all right, now we're getting really, really close to 0. Okay, let's find a number a little bit closer to 0. So let's do negative 0, 0, 0, 0. Oops. Negative 0.00001. Let's try that. Okay, it didn't want to do that one. Alrighty, let's try negative 0.000, just like that. I think I just did that one. 2, okay? So even negative, it's going to be a 2. Let's look on the right. You can already see it's going to do the same thing on the right. Okay, so we're approaching, as x approaches 0, from the right, where's y value going? Okay, so y value is increasing 1.5, 1.73, 1.879, 1.96. Let's do 0.00001, 2. Okay, so the limit as x approaches 0 of sine of 2x over x is 2. So we saw that both the left and the right hand limit were the same. So we have limit as x approaches 0 from the left of f of x, is going to be 2. And the limit as x approaches 0 from the right of f of x is also going to be 2. So from when we were talking about two-sided limits, so if the left-hand side equals the right-hand side, that means the limit as x approaches 0 sine of 2x over x is going to be 2. Okay. Indeterminate form. So that is 0 over 0. Okay, so a few strategies to approach indeterminate form. So remember, the limit cannot be determined except by further investigation or simplifying. So this is the algebra way to find the limit of indeterminate form. Now for one like that, you can't do algebra because there's nothing to be factored. That's the difference of squares, so there's nothing that can cancel out. So that one you would have to do graphically. Okay, but some, if you can see that you factor, try to take it out. So let's see. So we have so rational functions. So remember, p of x, q of x are polynomial functions here, right in lowest terms. Okay, you can use GCF or the cross method. If you've never seen the cross method before, guess what? So remember, you have ax squared plus bx plus c. This is ac here. This is b. This is over a, factor 1, factor 2. Okay? So you're going to be saying factors of AC that add or subtract. Now, if you're not sure which one is adding, it's going to add if this turns out to be a positive AC. It's going to subtract if it turns out to be a negative AC. So if this was like well, let's say this was 3 and this was negative 1, so then you would have a negative 3. So you would want factors of 3 that subtract to get whatever B was. That add or subtract to get B, this number there. So you already know what A is. A comes from there, and then factor 1, factor 2. And then you put them x plus f1 over A. It's not this complicated when you see it with numbers. Okay, and then if you have a denominator here, just move it that way. So you would have like ax plus f1, and then ax plus f2. Okay, but it's really not that complicated. It's just kind of the method used. Okay, another difference of squares. Okay, now in calculus, the difference of squares may look different. Like it could be x minus 2 squared minus 4. Okay, so that's still a difference of squares. Some difference of cubes, the same. Okay, so a cubed plus b cubed. I have them backwards. So this should be a plus. This should be a minus. And this should be a minus. You know what I should have done? I should have just made that a plus, not a minus. I guess it doesn't really matter. So it keeps the sign to start with, and then it just changes the sign there. But they're both the same. There. Okay, so let's do some examples.
Oops.
All right, so we got x squared minus 6x plus 9. So if I do it strictly by substitution, ooh, excuse me. Excuse me, it's allergy season. Okay, so if you went ahead and put in 3 here, you're going to get an undefined value here. So you need the factors. So you're going to need, so AC, if you're looking at the AC method, so AC is going to be 1 times 9, B is going to be negative 6. I'm just doing this because some people have never seen this before. I didn't see this until like 3 years from now. So A would be 1 here, that would be 1 here. So you want factors of AC, so that's 1 times 9. So factors of 9 that add to get negative 6. So that's going to be negative 3 plus a negative 3. So, also rule of thumb, do not you have to write your limit up until the point where you substitute in the values, okay? X minus 3, x minus 3. Don't be complaining yet, because when you get to instantaneous rate of change with the definition of a derivative, you're going to want to go back to this. Okay, x minus 3. Okay, so we got to cancel. And you remember, in a rational function, that's where a hole is, okay? So if we were to graph this, there would be a hole at 3, 0. Okay, so x minus 3 can't equal 0. Set that, you get 3, and then you put in the 3 after the reduced form. That's how you figure that out, okay? Alright, and then you have the limit as x approaches 3 of x minus 3. Now you can get rid of the limit. So you got 3 minus 3 equals 0. Okay, and as you can see right here, there's the limit approaches to the left and to the right. They are going to be y equals 0. Okay. Okay, let's do this one. So I see greatest common factor here. So that's going to be the limit as x approaches negative 4 of 2 times x plus 4. Factors of 12 that subtract to get 1 is going to be x plus 4 and x minus 3. So you have the limit as x approaches negative 4 of 2 over x minus 3 is going to be 2 over negative 4 minus 3, which is going to give you negative 2 over 7. So that's the limit there. Okay, this one, so this is a nice little problem. So we need factors of 10 that's so factors of 1 times negative 10 is negative 10. So factors of 10 that subtract to get negative 3. So that's going to be negative 5 plus 2. Okay, remember you can FOIL these and you get that same thing. Okay, 25. So AC, 1 and 25. So factors of 25 that add to get negative 10. So that's going to be x minus 5 and x minus 5. So that's a perfect square. Okay, so you're going to have the limit as x approaches 5 of x plus 2 over x minus 5. And that's going to give you 5 plus 2. Problem. This one's not going to exist. Let's see if it exists. Okay, so alpha y equals x squared minus 3x. This would be a point where I would say this would be a typo, most likely. X squared minus 10x plus 25. So we're looking at when it's 5. Okay. And I am right. At 5, there's a vertical asymptote. So 1, 2, 3, 4, 5. So C as X is approaching 5 from the left, it's going to negative infinity. As it's approaching from the right, it's going to positive infinity. So that limit does not exist. Okay? Okay? Okay. Alright, irrational functions. So irrational functions, so these are square roots. Square roots can't be in the denominator. So to find the limit, you could also use an approach to get square root out of the numerator as well to find these limits, okay? Usually, see, it's going to be 0. So what you're going to do is multiply by the conjugate. If you can remember what the conjugate is, it's this sign right here between the middle of the radical and this number, the sign changes, okay? So I'm going to make a little bit more room for me. Okay, so I'm going to multiply by the conjugate here. You do not change the sign, you're only changing that one. Okay, so you're going to multiply top and bottom by the conjugate. Now, notice something, this will make your life easier. This is a difference of squares, okay? Remember, the difference of squares formula is a minus b times a plus b equals a squared minus b squared. So do yourself a favor and make this a difference of squares, okay? As long as this sign and this sign is different, see? So a in this example would be the square root of x plus 1 and b would be 1, okay? So just use the formula. It's going to make your life easier. Please listen to me. Okay? So this is going to be the square root of x plus 1 squared minus 1 squared. Okay? So see, a squared minus b squared. A was the square root of x plus 1 and b was 1. B is not negative 1. This is the formula. It's just b equals 1. Okay? Over x times the square root of x plus 1 plus 1. Do not distribute, okay? Do not distribute. Something's going to cancel out. Just watch. Okay, so that's going to be x times the square root of x plus 1 over, you undo a radical by squaring it, so that's going to be x plus 1 minus 1. And you see something's going to cancel out, I hope. Okay, x's cancel out. So you got the limit as x approaches 0 of the square root of x plus 1, which is 0 plus 1 plus 1. Square root of 1 is 1. 1 plus 1 is 2. Okay. Next one. Okay, so this is going to be an example where we have to take the conjugate of the numerator. Okay. So, let's do that. So where we're changing sign is this right here. So we're going to, let me make this a little bit bigger. Sorry, this program makes me have to have my camera behind. So it didn't do that the first time, but now it's doing that. I wish it didn't, but yeah. Multiplying by the conjugate, so I'm just changing this to a negative. Okay, top and bottom, difference of squares again, so you have a plus b times a minus b. You can FOIL if you want to, you're not going to be wrong, but the outside and inside term of FOIL is going to cancel out. Okay, so you're going to have a negative 2 times square root of x squared plus 2 times square root of x squared plus 2. It's just easier to use the formula, but whatever makes you happy. Okay, so difference of squares, so that's going to be the square root of x squared plus 4 squared minus 2 squared. Don't distribute the bottom, something's going to cancel. X squared plus 4 minus 4. Now if you want to, you could actually go ahead and start like substituting now, but for viewers who need a little help with algebra, I'm keeping on going. Because all calculus is algebra with a cherry on top of calculus. Okay? So this is all algebra. The only part that's calculus is the limit as x approaches 0. And so you got x times square root of x squared plus 4 minus 2. So x squared over x is just x. X squared plus 4. Okay, I'm going to go ahead and plug in my 0, which is going to be 0 because you put in 0 here. Anything in the bottom doesn't matter because 0 over something is 0. But I'll go ahead and put it in here for you. Just to show the substitution. Okay. Okay, so limits of piecewise functions. So we're going to do this next graph, and we're going to graph it, okay? So how I do piecewise, I kind of line them up horizontally. So I'll do like f of x equals 1 over x plus 2, and x is less than -2. We'll start with that one. Okay, you always start at the value this is. Yes, it does say x is less than 2, but start it here, just put a hole where that is. So I already know if I put a -2 here, I'm going to get undefined. This is a vertical asymptote. This is a radical function. So if I do f of -2, I'm going to get a vertical asymptote. Okay, now I'm going to do a number less than -2, so I'm going to just do -1 or look for something that's going to be easily subtracted. So -1 looks good. So f of -1 is good. Oh, -3, I'm sorry. -3. No, I don't want to do -3. Well, I guess it doesn't matter. -3. So that's going to be 1 over 5. Okay. F of -4 is going to be 1 over -4 plus 2 is -1. Okay. That's good points for that one. Okay, so you got 3 x values there, sort of. All right, and then x squared minus 5. Okay. So use everything. Don't use something greater than 2 here. So you're going to start at f of -2. So -2 squared is +4. 4 minus 5 is -1. Since this does not have an equal to underneath, this is going to be a hole. Let's put that there for your reference. And actually it really doesn't matter because it's going to be a vertical asymptote here anyway. So yeah. F of 0 is going to be -5, and f of 3 is going to be 9 minus 5, which is 4. Now we're going to go over here. F of x equals the square root of x plus 13, where x is greater than 3. So you have to start at 3. So you're going to have 3 plus 13 is 16. So f of 3 is going to be 4. That's going to be a circle. Oh, I forgot here, this is the equal to, so this is going to be filled in. That point's going to be filled in. All the points in between are filled in. It's just the end points of the piecewise you got to be careful of. So f of 3 equals 4, and then f of, let's see, what's going to get 25? 12. So that's going to be 5. Okay, so let's draw a rough sketch. I'll just do that down here. Really rough sketch. So we got like a vertical asymptote here, but we also got like an undefined point here, so I'm just going to go, so -2, -1. But the other points are going down. Okay. It's not crossing 2, I just... Okay, so then we have 0, -5, 1, 2, 3, 4, 5. And then 3, 4, 1, 2, 3, 1, 2, 3, 4. So this looks something like this. Something like that, anyway. And then we have our square root functions. So at 3, 4. Now, 4 is already taken. It is a circle, but it's already filled in, so it's not like you have to do that. So 3, 4, and then 12, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's my piecewise function. Okay, so now we're going to find... So the limit as x approaches -2. Okay, so is there a limit as x approaches -2? So is there going to be a left and a right hand limit that are going to go to the same area? And the answer is no. So the limit as x approaches -2 from the left is -infinity, and the limit as x approaches -2 from the right is going to be -1. So that does not exist because the left and the right hand limit don't equal. Okay, so the limit as x approaches 0, that does exist. So as x approaches 0 from the left, it goes to the same place, so you can kind of bring your, yeah, like that. Okay, so that is 0, -5, so that limit does exist. Limit as x approaches 3. Okay, so let's look at 3. 3 is right here. So the left hand limit equals, and so does the right hand limit, so they come together like this. So that does exist at 4. Limit as x approaches -2 from the left, I know what that is, from -2 from the left is a negative infinity because it's going down. Limit as x approaches -2 from the right is going to be -1. And then the limit as x approaches 3 from the left is going to be 4. Okay, and that's all I have for you on limits. Another thing you can do for limits too, some limits will have complex fractions. I'm just going to do one problem. I'm just going to simplify one. I'm not going to do a limit one. So let's say you have 1 over x plus 2, and then you have x over x plus 2 minus 1 over x. Okay? So yes, you can get the common denominator and subtract and then divide and then multiply, but there's a much easier way, okay? Just letting you know, there's a much easier way. Okay, so what you're going to want to do is find the LCM. You're going to point out your denominator. So I got x plus 2, and x. So I got x plus 2, and then I'm just going to put the other one right there, and then I got x. I just like my x's on the left-hand side. Okay, LCM, just bring everything down. So my LCM is going to be x times x plus 2. So what I'm going to do with that x times x plus 2 is I'm going to multiply every single term by x times x plus 2. So I'm going to multiply it here. So x times x plus 2. X times x plus 2. X times x plus 2. And what happens is denominators are going to go away. Watch this. Goodbye. Watch your parentheses there. Okay, so that's how you simplify a complex fraction. Okay, y'all have a good night. Okay, I hope all was well with all of you. And good night. As you can see, I need to go to sleep. Okay, so bye.